You know, if you're a Delphi developer, you have lived with this paradox for years. On one hand, you've got the incredible power of the FireMonkey framework. I mean, the ability to build cross-platform apps from a single codebase is just a game changer. But on the other hand, there have always been those persistent, nagging performance issues that kind of held it back. Well, today we're going to dive deep into how RAD Studio 13, which is also known as Florence, isn't just tweaking the engine, it's performing a complete heart transplant. We're going to break down exactly how they're finally solving FMX performance. For good.
So, here's our game plan. First, we're going to really define the problem, the thing that has challenged developers for so long. Then, we'll get into how RAD Studio 13 is a truly revolutionary fix. We'll break down the two main pillars of its solution, a complete rendering overhaul and a brand new animation engine. And to wrap it all up, we'll finish with a clear, actionable roadmap that you can literally use in your own projects starting today.
All right, so to really grasp why this update is such a massive deal, we have to start with the central conflict that FireMonkey developers have been wrestling with for years. It's this constant battle between the incredible promise of the framework and some of its historical pain points.
I mean, let's be honest, the promise is absolutely amazing, right? One team, one set of code, one UI design, and bam, you can deploy truly native applications across every single major desktop and mobile platform out there. It is the holy grail of development efficiency. But, as many of you know, there's always been a catch. And right here, this is the pain. This quote absolutely nails it. That feeling of jank or stuttering when you're just scrolling a simple list or trying to run a smooth animation. It's that subtle, or sometimes not so subtle feeling that the UI just isn't quite native. This has been the ghost in the FireMonkey machine for a long, long time. Until now.
So, that's the problem. How does RAD Studio 13 actually fix it? Well, with Florence, the approach isn't about patching the problem or putting a Band-Aid on it. We're talking about a fundamental architectural revolution that's designed to eliminate it for good.
And this is the most crucial point to understand. It's a total change in strategy. See, previous versions, they might have offered some high-level optimizations or maybe a few component-specific fixes. Florence goes right to the core. It re-engineers the entire rendering pipeline from the ground up. This is a foundational change, not just a surface-level tweak.
And what's really smart is that before they even touch the app performance, they fix developer performance. The entire IDE is now a true 64-bit application. Now, what does that mean for you? It means no more out-of-memory errors when you're working on massive projects. It means faster code completion and navigation, and a much more responsive debugging experience. It's simple, really. A faster, happier developer is going to make a faster app.
Now, for the first pillar of this whole solution, the graphics engine. And this, my friends, is where things get really exciting. Embarcadero didn't just optimize the old engine. No. They ripped it out and replaced it with an absolute world-class powerhouse.
So let me introduce you to Skia. If you have ever used Google Chrome or, any Android phone, you have seen Skia in action. This is the battle-tested GPU-accelerated graphics library that powers two of the most widely used pieces of software on the entire planet. It's incredibly fast, it's reliable, and now it is at the very heart of FireMonkey.
Okay, so you're probably thinking, this sounds amazing, but it must be a nightmare to implement, right? I'm probably looking at weeks of refactoring my old code. Well, brace yourself. How do you unlock all this power? You add this one single line of code to your project startup. That's it. Global use Skia equals true. A single line to completely replace the rendering engine of your entire application with a state-of-the-art GPU-accelerated one. It's almost unbelievable how simple it is.
And what is the result of that one little line of code? Well, how about a potential graphics performance increase of up to 50%? We're not talking about a minor tweak here. This is a massive leap forward in rendering speed and efficiency. And the best part? You're also improving the visual quality with superior anti-aliasing. It's faster and it looks better.
This table does a great job of showing how all the pieces of this new pipeline work together. So at the very top, you've got Skia, providing that core GPU acceleration. Now on Android, that pipeline can use Vulkan, which is like a direct hotline to the graphics hardware, lowering CPU usage and saving battery. Then you've got SKSL shaders for ridiculously fast custom visual effects. And get this, even simple things like bitmap operations are now offloaded to the GPU. Every single piece is designed to free up the main CPU thread and just maximize raw speed. So faster rendering is huge, but it's only half the battle. To really kill that stutter and jank, you also have to solve the problem of timing. And that brings us to the second pillar of Florence's performance revolution, the brand new display link service.
To get why this is such a big deal, you have to understand the old way. It used software timers. Think of it like a drummer in a band who's kinda sorta keeping time but isn't really listening to the rest of the musicians. It tried to fire out a regular interval, but it wasn't connected to the screen's actual refresh cycle. This is what caused missed frames and that dreaded jank. The new display link service, on the other hand, hooks directly into the hardware's vertical sync, the V-Sync. The screen itself tells the app the exact moment it's ready for the next frame. It's perfect timing, every time.
So let's talk numbers, because this is why timing matters so much. On a standard 60 Hz display, which is what most phones and monitors are, a new frame is drawn every 16.67 milliseconds. That is your total budget, your entire time limit. To get smooth motion, your app has to process user input, run all of its logic, and render the entire scene, all inside that tiny, tiny window. If you miss that budget, even by a hair, you drop a frame and the user sees a stutter.
So the critical takeaway here is how Florence attacks every single part of this process to stay within budget. Input handling is now faster. The updated Delphi compilers generate more efficient application logic. The new Skia engine has absolutely slashed the rendering time. And finally, the display link service makes sure the app waits for the perfect moment to start the next cycle. It's a complete holistic approach to hitting that 16.67 millisecond target.
All right, so we've seen the problem, we've gone deep into the revolutionary new technology. Now let's bring it all home and turn this into a clear, actionable plan that you can apply to your own FireMonkey applications. Here it is, your 5-step checklist to unlocking true native-level performance. First things first, get your project migrated into the new 64-bit IDE. Second, enable Skia with that one magic line of code. Third, let the display link service handle your animation timing. The good news is it's now the default, so you basically get this for free. Fourth, for your Android builds, make sure you're prioritizing the Vulkan backend to get that maximum efficiency. And finally, start using some of the new component-level optimizations, like the isVisibleChild method in scroll boxes, to stop the app from wasting time drawing things that aren't even on the screen.
So by completely rebuilding its rendering and animation pipelines from the absolute ground up, RAD Studio 13 Florence is making a very powerful claim that the long-standing performance gap has finally been closed. And that leaves us with one last thought to ponder. With all these changes, is this the moment? Is this the update where FireMonkey UIs become truly, completely indistinguishable from their native counterparts? All the evidence we've seen today suggests we are closer than we have ever been before.